Hey, hello there, and welcome back to another Advent of Code video. So today it's technically December the 7th, but I haven't gone to sleep yet, so to me it's still December the 6th. And I'm back for more Advent of Code, and my cat just got on my lap. You can see her here. Very cute. And the question is, can I solve a Advent of Code puzzle being a bit, you could say drunk, or maybe tipsy? Yeah, let's say tipsy. So I very much doubt that is the case, but we shall give it a try. Maybe I should stop talking and maybe talk a bit less than I usually do. So this is look at this. Day 7 is about to be published. Should I try to speedrun day 7 while being a bit not drunk? Well, yeah, I have like 3 pints of beer. No, I'm not really cut out for like speed competitions on this thing. Like the people who do this are very, very capable. But I have my glass of water and my bottle of water just in case. So I think I am prepared to give a try to day 6. So day 6, wait for it. The ferry quickly brings you across island. After asking around, you discover that there is indeed normally a large pile of sand somewhere near here, but you don't see anything besides lots of water and the small island where the ferry has docked. As you try to figure out what to do next, you notice a poster on a wall near a ferry dock. Boat races, open to the public. Great prize is an all-expense-paid trip to Desert Island. And it's desert, not dessert. I always have trouble pronouncing the difference between those two. But desert is the kind of climate or biome, and dessert is what you eat. It's kind of the difference like between having lunch and lunch in a rocket. But anyway. So, boat races, I guess. Yes, that must be where the sand comes from. Best of all, the boat races are starting in just a few minutes. Awesome. So, you managed to sync up as a competitor in the boat races just in time. The organizer explains that it's not really a traditional race. Instead, cat is turning on my lap. Instead, you will get a fixed amount of time during which your boat has to travel as far as it can, and you win if your boat goes the farthest. Okay, so it's like a length competition. As part of syncing up, you get a sheet of paper, your puzzle input. That lists the time allowed for each race and also the best distance ever recorded in that race. To guarantee you win the grand prize, you need to make sure you go further in each race than the current record holder. Okay, so we are really like tryhards on this. Like we want to beat every race ever. Awesome. The organizer brings you over to the area where the boat races are held. The boats are much smaller than you expected. They are actually toy boats. Okay. Each with a big button on top. Holding down the button charges the boat, and releasing the button allows the boat to move. Boats move faster if their button was held longer, but time spent holding the button counts against the total race time. Okay. Cool, so you have to like charge the boats and then they release and go. You can only hold the button at the start of the race, and boats don't move until the button is released. Okay. For example, time, distance, and this is an input. This document describes 3 races. The first race lasts 7 milliseconds. Okay. Kind of a short time. The record distance in this race is 9 millimeters. Okay. These are very short times and distances. The second race is 15 milliseconds, and the record distance in this race is 40 millimeters. The third race is lasts 30 milliseconds. Okay, yeah. Okay, this is very short times. I bet that the actual input has like much longer times. Oh no, actually no, these are still very short times, like in, you know, tens of milliseconds. So what's going on here? This is very weird. Like, really, what's going on? Are we like machines or something? This is a sort of like an existential crisis for me. Like, are we supposed to like race in a couple of milliseconds? Like, your toy boat has a starting speed of 0 millimeters per millisecond. For each whole millisecond you spend at the beginning of the race holding down the button, the boat's speed increases by only 1 millimeter per millisecond. So because the race lasts 7 milliseconds, you only have a few options. So are we like computers or something? Like, I was under the impression when reading Advent of Code puzzles that I mean that the protagonist of this was like an elf helping Santa, and you know, have lots of other elves going around and doing their things. Or like maybe we are human and the elves are like weird and all of that, but we the only human are like the reasonable person who can program and do shit. But if we can do things in like single milliseconds of time, I'm now thinking of like, are we machines in this? Is this like a plot twist on Advent of Code? And I'm sort of drunk and only now realizing this. Maybe this makes sense because like Santa has to travel around the world in 24 hours and visit like so many places around the world. It's like a massive salesman problem. So yeah, Santa definitely is some sort of like superhuman machine, but I guess we elves or whatever we are also very fast machines, and I just realized that. That's deep, man. Okay. So what did I just read? Yeah, we have a starting speed of 0 millimeters per millisecond. Okay. For each whole millisecond you spend at the beginning of the race holding down the button, okay, you charge it and the boat speed increases by 1 millimeter per millisecond. So because the first race lasts 7 milliseconds, you only have a few options. So these are all the options. You don't hold the button at all, that is, hold it for 0 milliseconds, and at the start of the race the boat won't move. You will have traveled 0 millimeters by the end of the race. Hold the button for 1 millisecond and well, then the boat will travel at the speed of 1 millimeter per millisecond for 6 milliseconds, reaching a total distance of 6 millimeters. Okay. Then if you hold it for 2 milliseconds, blah, 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 yeah, it travels for 5 milliseconds and it travels 10 millimeters. You hold it for 3 milliseconds, it travels for 4 milliseconds and goes 12 millimeters, and then for 4 milliseconds holding is the same thing, and then you should sort of hit a diminishing returns. If you hold it for 7 milliseconds, that's the entire duration of the race. You never let go of the button. The boat can't move until you let go of the button. Please make sure you let go of the button so the boat gets to move. 0 milliseconds. that's written in a very funny way. Since the current record for this race is 9 millimeters, there are actually 4 different ways you could win. You could hold the button for 2, 3, 4, or 5 milliseconds at the start of the race. In the second race, you could hold the button for at least 4 milliseconds and at most 11 milliseconds and beat the record, a total of 8 different ways to win. In the third race, you could hold the button for at least 8 milliseconds and no more than 19 and still beat the record, a total of 9 ways you could win. To see how much margin of error you have, determine the numbers of ways you can beat the record in each race. In this example, you multiply these values together, you get 288, that is 4 times 8 times 9. Determine the number of ways you could beat the record in each race. What do you get if you multiply these numbers together? Okay. After being mind blown by thinking that we are now machines, and this input is not very big or anything, so I think part one seems pretty straightforward. That sounds like famous last words, I guess, but let's jump into this. So I have still day 5 here, which I spent like 4 or 5 hours refactoring. I will upload those videos, but let's copy the templates. Let's call this thing day 6, and I don't remember the name. Wait for it. Oh, wait for it. Maybe if we wait for it, part 2 will kick our asses. Wait for it. Okay. And let's copy now the inputs. This is gonna be day 6. And what do we have? We have the actual input. So this is this. Now this is like aligned by columns, but I think it should be fine to parse. We have the sample input. Where is it? It's this thing. Sample. And the sample output, like what we want is 288. Okay. So day 6, wait for it. Okay. It seems pretty straightforward, right? Let's implement all of this in main. So we are going to we're gonna have 2 lines. Yeah, let's say what are the lines? This is the sample. Actually, I want to like close everything else, like declutter the screen, increase the font size, open the sample again, 06 sample. What? Where did I put the sample? Did I modify? Oh yeah, I modified the template. That's I modified everything in the template, okay. I don't know why that is. Maybe, like, am I drunk or something? No, that cannot be. Man. Yeah. This is gonna be trash. Okay, we have the sample. So the first lines are the times, the second line is the distances. So let's call this thing times, distances, and let's actually first say lines. It's gonna be in. Hello, Simone. Okay, my cat wants to be on my lap. Come on, Simone. Okay. Inputs, lines, and collects. Sure. And then we are going to pattern match these two things. Lines, sure. Or else, let's say error. Expected input to have two lines. Sure. Then what? Then we want to, well, get rid of this and parse these things as numbers, right? Yeah, let's try and let's not generalize anything, just say shadow these times and say times strip prefix time. Sure. Okay, and then say split, no, this, okay, no, here, okay, or invalid times just say invalid input, valid input. Okay, so if we had a valid input, then we're gonna say map. We're gonna try to map into parse and then try collects. And after all of these, yeah, we're gonna collect this into a vector, I guess. Does this make sense? Okay. Oh, map. No. What do I want? I want to split white space. Sure. Oof. No, I want to have this try map from iter tools. Okay. What else? Oh, you don't know what to parse into? Yeah, just parse into numbers. This is horrible, but let's copy this. Those were the times, these are the distances. Sure. And it's not time, it's distance. And why could this not work now? What? Oh no, no time, no times, distances. Okay, yeah. Let's see what we have. Print line times so we're gonna cargo run day 06. Wait for it, wait for it. Inputs 06 sample. Okay, we parsed this thing correctly. Great. Now, what do we want to do? So for each of the races, that is like combining these times and these distances, this code looks gnarly. Yeah. Let's not think about that. For each of the races, we want to see how many possibilities we have of winning. So that doesn't seem too complicated. How does this thing call it? Numbers of ways you can beat the record. Okay. So we're gonna say answer 1, and let's just give this thing type. So we're gonna combine the times, iterate over them, zip them with the distances, and then we are going to map each of those into a number of ways you can win that race, and then we're gonna multiply them, right? So products, yeah. And how do we map this thing? So we are gonna have a time and a distance, and what do we want to do here? Okay, and after having that, we're gonna just print the answer. Okay. So how are we going to do this? So I guess we can do it very simply by trying all the different times. So going from 0 up to and including the given time. What are we going to do with this? We want to know if we can win the race by holding the button that amount of time. So we want to compare it with this record distance. So I guess we can try for each of these numbers. Yeah. And we're gonna just filter the ones that are actual possibilities and then count these things, right? Yeah. And maybe instead of use 32, let's make it a U size, so that's count, that's what we want. This time Sure. We can. This is a bit ugly. So does zip. Oh yes, it consumes the thing. So let's just iter this. So yeah, fine. I want to filter which of these times will let us time t will let us win the race. So time t, this is actually the hold time, how much we are holding the button. So if we hold the button this hold time, we are going to have, we're going to consume this time from the total time of the distance. I guess we don't have to go up to time, because we know that if we hold it for exactly that amount of time, then we are not going to move anywhere. So that's not necessary. And actually, like the 0.6 input, yeah, the 0 case is also not really necessary, because like you're not going to advance if you go at 0 speed. But okay, we can start from 0. So the velocity, now the velocity or speed is going to be the same as the hold time, so that's fine. So this distance is actually the record distance. So the distance that we are actually going to travel if we hold the button for this hold time is going to be time minus hold time times, so our speed is going to be the hold time. So this is our speed times the time that we have to remaining to run. So that's it. That's going to be the distance, and we are able to win the race or beat the record if our distance is greater than the record distance, right? Is this it? Does this get us the answer? Yes, this is the sample answer. And input, it's a number, it didn't fail. So let's submit this. And yeah, I think this was like the easiest puzzle of this year's Advent of Code. I'm very glad that I'm doing this in this condition. Part 2, this is where things might get interesting. So as the race is about to start, you realize the piece of paper with race times and record distances you got earlier actually just has very bad kerning. So kerning is how you like space out letters on when you print them. So it's this kind of thing, like munching up or yeah, making the A and V here closer so they look nicer instead of like putting one glyph completely after the other. But bad kerning? What? There's really only one race. Ignore the spaces between numbers on each line. So the example from before, oh okay, so now we're going to have big numbers. So this thing has a really bad kerning, so it's just a big number. Now you have to figure out how many ways there are to win this single race. In this example, the race lasts 71,500 530 milliseconds. So okay, it makes more sense. Now we are not machines. It's an actual race of 71 seconds, which is something that we humans can comprehend. And the record distance you need to beat is 540,000 milliseconds. So yeah, 540 meters. You could hold the button anywhere from 14 to this time milliseconds and beat the record. A total of this amount of waves. How many waves can you beat? Okay, the same idea, but with the real input. This is going to have 2, 4, 6, 8 digits. That is tens of millions. That's not too bad. I bet you we can brute force this. I mean, if we could brute force the previous day, day 5, we can definitely brute force this. So let's go for it. So now it's only a single time and a single distance. Awesome. So I guess I could reinterpret this thing. Let's call this thing line 1 and this thing, whoops, where am I? This thing line 2, and I want to have this be called times S, and S of course for string. Why are we dereferencing here? What? How many? No, don't borrow this. What are you doing? And this thing is oops, this S. Okay, so these are the times and distances for part 1, which makes a lot of sense, sure. But for part 2, we want to grab these two things, remove all the white space, and then parse the two as single numbers. So let time be, we're gonna use, we said that it was millions, so it's fine to use, I think, a U32. If I can even type, this is gonna be times S, replace space with nothing. What does replace? Gives us back an owning string, so we're gonna parse this guy, and great, and then the distance for this particular race is gonna be the dist S. And then we are going to do just the same thing that we were doing here, but for this single race. So going to go from 0 up to this time of this race. This is going to be the yeah, sure. No, and this is actually the record distance. So we're going to do that, and this is going to be the second answer. And let's just print this. Let's run this in release mode. What? Parse int error, positive overflow. What? Oh, because the distance is a much larger number. Oof. That's a very bad problem, sure. I wonder what happens if I do just use 64-bit numbers. Run again. It's just spit an output, and if this is the correct answer, I'm going to be very happy. And I am. Oh man, I'm so lucky that this was just the easiest puzzle that we have so far. This was easier than day one. I'm sure, like. It was a breeze. I mean, I'm sure I'm not really the sharpest tool in the box right now, but it wasn't so complicated to get at this. So I think that's it. I don't think I want to like try anything else. Just commit this. There is a bit of repetition between this thing and this thing because it's basically the same fucking thing. So this, let's use a little bit of brain cells, and actually if we run check all command, we are missing the answer for let's check the advent calendar. Oh, look at that, the island looks lovely, but the answer for the sample on the part 2 should be this. So let's go to 06 sample out. The answer should be this, and these outputs. Well, let's actually do answers. Yeah, this thing, and it runs really fast. Like hell, if we do build, no, cargo build, yeah, in release, and we time, well, this thing, but not this thing actually, this should be day 6, and for the day 6 input, yeah, it runs in 46 milliseconds, so it's, I mean, it's acceptable. We can surely do something faster, and I think I can think of a way of doing this in a like binary search kind of way, but this is not so bad, and we can even like trivially parallelize this by trying all of these things with a parallel iterator, and that will speed things up like by 8-fold or something. So yeah, this just works. And if we now run check all, this passes, that's great. So let's add all of this. This is an acceptable answer, and let's try to use just a smidge, little bits of brain power to extract what? This function, I guess, which will take a time and the record distance and gives us what? The ways that we can beat the record. Yes, let's extract this into a function, and these are ways to beat records. And this is the time of the race, and this is the, so yeah, let's call this thing race time, and this is the record distance for that race time, and yeah, that's exactly what we want. And so now we can do the same, but inside of this map function. And look at that, it didn't work. The arguments are incorrect. Oh, sure. This thing is expecting a 64-bit number. So what am I going to do? Of course, I'm going to just use 64-bit numbers for this. And that's it. Great. And you know what? Even greater than that, I think we don't even need these things to be vectors, right? I'm thinking even more than my little brain cells can do at this time. We can just use iterators for this. This will be an iterator for times and an iterator for distances. And can we zip iterators? No, because we these parse things could fail. Darn it. So if parsing fails, yeah, let's go to the vectors. That was a good idea, I think, but I don't think I can think about that. So is replace what we want. Do we have more split ASCII? Yeah, no, replace is exactly what we want. Replacing spaces by nothing. And yeah, this thing seems to work really nicely. So I think that's it. This was I think the easiest puzzle of this year's Advent of Code. So let's add day 6 solution and call it a day. That's it for today, I guess. And if you have been, thanks for watching. This was a very peculiar solve, but it was a successful solve, I guess. I was really lucky to get this simple puzzle this time. So if you have been, thanks for watching, and as usual, see you later. Bye bye.